Hello and welcome to my talk, running Docker in production on AWS. I have 30 minutes and I hope I keep the time. And first a disclaimer. If you ask me how to run Docker in production, my answer would be don't do it. So talk is over. At least without being aware of the risks. So production is like the name explained, production. So you need to take care of the risks. And Docker ecosystem is still young and evolving. A lot of new releases, breaking changes, and so on. So move carefully and gain experience. Start with low-risk systems. Don't start with your mission-critical application. Listen to the critics, but judge yourself. So, for example, there's a blog post just published this weekend, Docker in production history failure. Read this, read the comments, and judge by yourself. Okay, if you're still with me, then my agenda would be some challenges, or the challenges you need to solve from going from your development environment to a production environment with Docker. I will talk especially about using Docker in combination with Elastic Beanstalk. I will give you a demo of this, and afterwards a little bit discussion of alternatives. And so just let's start with the challenges. So you have your application, you have Dockerized it, it's running locally, so what do you need to solve if you're going to production? First thing, of course, you need the infrastructure on AWS. This means EC2 instances and security groups and load balancers and stuff like this. You need to set this, to create this. You can all do this manually, but of course, this is not production ready. So you also need to solve the problem of to install the Docker engine. You also need then to handle these multiple containers on different hosts on different nodes. So you need to orchestrate them, to start them, to stop them, to deploy new containers. You need to configure these containers. You need to give them some information about the environment. You need to integrate with AWS. At least on AWS, it makes sense to use your already existing services like RDS for SQL databases or all the other services that are available in AWS. And you need to scale, maybe to auto-scale, and you need to do monitoring and log management. And I think this is not a complete list, but just the start of things you need to consider. So, AWS Elastic Beanstalk, what is it? It's an application platform as a service with Docker support. It's fully managed by AWS. And it's a service to deploy and scale web applications or web services. There is also support for background, so-called worker applications, and you can combine multiple, so you can do kind of microservices architecture with it. But the blueprint architecture of Elastic Beanstalk, the sweet spot is web applications. It has a good integration with other AWS services. It's also highly customizable if you understand the low-level pieces, and I will come back to this point later on. So, like explained, a typical Beanstalk application is looking like this. You have a load balancer, you have DNS entry pointing at your load balancer, you have one or multiple web server, web applications running. These are typically configured with auto-scaling. You have you have a SQL database and maybe some other stuff like a NoSQL database or caching or so on. But at the core, this is a typical application. So, the talk is about Docker, so Elastic Beanstalk and Docker. How does these two pieces fit together? Beanstalk originally started with language-specific platforms, so for PHP, for Ruby, for Java, and later on Docker support was added. This Docker support is based on another AWS service called Elastic Container Service, which is specifically targeted at managing containers and is the lower level management service. You can, of course, use ECS alone, but later on, I think I will explain what the advantages of using it in combination with Elastic Beanstalk. So ECS, how is it working? It's working like most of the other container orchestration tools out there. Most of these have some similar architecture. You have a cluster of machines. On these machines, of course, there's a Docker daemon, which starts, stops, manages the containers. The containers are running on these different nodes. And you have one component, this is called ECS agent, something similar you will find in all the other solutions too. And these agents are talking back to the master service, master controller, which is responsible for cluster management and for scheduling. Scheduling means to put your container on a specific instance or on a specific node. And if you have Docker, and you're familiar with Docker, you need Docker images, and these Docker images need to be stored somewhere. And this is a container registry, and part of the ECS or combination complement to ECS is a ECR, the container registry running by AWS. You can, of course, use Docker Hub too, but if you're using AWS, you have a private registry built in. So, what to do? 3 steps to deploy an application with Elastic Beanstalk and Docker. First thing, you need to have dockerized application, and you need to push this this application into a registry where it is available to get pulled from the Beanstalk or from the ECS. You need to create and upload a so-called Beanstalk application bundle. In simple words, the Beanstalk application bundle does not contain the application in itself. This is a case for the names comes from the history of being language specific, and in the other cases, it's the application itself. For example, in the Java case, it's a WAR file. And in the Docker case, it's just a reference, a specification file pointing to the image. So think of this as something like a Docker Compose file. And you can have some more information inside of this bundle, which tells the system how to run your container. And then you need to actually start this process. This is to deploy the application. And deploying the application means you need to deploy this into an environment. You can have multiple environments per application. So in production, this environment is typically not alone. You have test environment, integration environment, production environment. And this is, I think, very common scenario. And the Beanstalk system supports this. And if there's no environment existing, then an environment will be created. So, explained with graphics, this is again, first step, push the image. Second step, upload your bundle. Third step, manage, create, start the application. So then it's demo time, and let's see if this works. Let's first have a look at the console. There is also the Elastic Beanstalk console, and like you see here, this is a welcome screen, and there's no application, no environment deployed yet. You can use the graphical user interface, but I will use something else, which is called the Elastic Beanstalk command line interface, in short EB. So, let's see. What is my demo application? My demo application is just a JHipster application. It could be anything else, but JHipster creates a complete application, and it's perfect for demoing this stuff because it also creates a Docker file. So I already have this locally. This is the demo application. Like you can see here, it's created using JHipster. You can find JHipster as an application generator project, and I did not modify anything, just generated application out of the box. It also generates a Docker file, but it doesn't matter. You can also write it on your own. And it also creates a compose file to run this locally. So let's see. First step, I've already built and compiled this to save some time. So we will start with step 2 to build the Docker image. This will just copy the WAR file into the container image. And afterwards we will have a Docker image which we can run locally. So to see this, let's see, there is Devox. This is a new image just created 9 seconds ago. So next step is to push this into the registry, but let's check this out locally before. So we will run just for demonstration purposes this application locally in environment, development environment. This Docker compose file will start the actual application, the Java application, and also a second container, the MySQL container. And then this Java application will connect to the local MySQL container, and everything is running locally. And there it is. And let's check this. And yeah, like you see, this is a Java hipster application just generated. I can log in. And behind the scenes, there is all kind of stuff coming from Spring Boot. You have health checks, you have log files, and so on. But this is just coming from JHipster. And what I want to demonstrate is this is running locally on port 8080. So then let's stop this. We develop this, we debug this, we are ready to run. And now we would like to go to production environment, or maybe integration environment first. So we need to text this file. But before, I've explained I'm using the AWS registry, so I need to log in. And then I need to tag my file. And like you see here, this is like you referencing to the ECR, the AWS container registry. So this means don't store it on Docker Hub, but store it inside of AWS. And then you need to push it. And this pushes this to the AWS registry. And so step 1 is done. Now we need to create our application bundle and to start up the application. And for this I need to switch to this other directory. This is a typical setup of the command line environment. You have a directory with some specification files, and I will start up the process in the beginning and afterwards explain a little bit, because this will take a couple of minutes to be ready. This command line then now talks to the service and does a little bit of stuff. First thing is that it uploading this zip file. So it's zipping the local directory, and this zip file is then uploaded to S3. And this is exactly what I've explained before, this application bundle. So this is step 2. This is now done. And then the next step is it has created this application called DevOps for this demo. And now it's creating an environment called prod. And this needs some time. And while this is working, I will explain a little bit about what is happening behind the scenes. So in this moment, it's safe to Control C, so we can stop this. And let's switch back to the presentation. Or not? No, there's it. So this was your user interface. Step 1, push the image. Step 2, upload the bundle. And step 3, create the application or deploy the application. Step 2 and step 3 is combined with the EB command line tool. And what happens behind the scenes? Behind the scenes, Elastic Beanstalk uses a lot of the other stuff. You don't know this in the beginning, but it's helpful if you want to customize this. So Elastic Beanstalk does not do the work on its own. It just creates a so-called CloudFormation stack. CloudFormation is another service which is then responsible to read the specification, the stack specification, and to execute all the things which need to be done to create all the resources which are needed. So what are these resources? Of course, like I explained before, we need the nodes. So these are EC2 instances. And so Amazon EC2 CloudFormation is calling EC2 to create the VMs. It's also creating a so-called ECS cluster. This is an organizational concept, and this also creates a load balancer, which are positioned in front of the instances. It also creates an entry in Route 53, which is a DNS service. Then it creates auto-scaling policies inside of CloudWatch, and you can also customize this process by inserting and adding your own concepts. This would be that there are other resources which would be created too. For example, you can create a cache layer using Elastic Cache, Redis or something like this. You can create NoSQL services like DynamoDB or something like this. So, and then let's have a look what's happening. For this I will switch to the console. And if I restore this, then I see that this is already have created the DevOps application. Inside of this there's this environment called prod. And if I go inside of this, then I can see the events which are happening, and I can see that it step by step creates all the resources. So let's use time and look into the Beanstalk specification file. What we have here is that we have the main part. This is what I explained before. This is a specification file, a file called dockerrun.aws.json, and it contains the actual container definitions. So it gives the container a name. It tells or specifies which image to use, and this is exactly the image we have just pushed up to the registry in the step 1. Some more specifications like if it's essential, this means that you need to restart this container or this whole system if it's not running. ECS behind the scenes is also monitoring this and restarting the container if it gets stopped. You need memory specification, you have some port mappings and so on. This is very similar as a Docker Compose file, and if you are coming from this, it's just a little bit different syntax, but in the end, it's the same idea. In development, we have used 8080, but in production, I would like to use port 80. For this, I'm using a second container. Also to demonstrate that you're not restricted to only one container, but you have an array, like here in the JSON file. So we have our jhipster container, but we also have an Nginx proxy in front of it. And this allows me to show you this link concept, that this one container, this Nginx container, is linking to the jhipster container to proxy it. And this also allows me to show you a concept of that bundle, the application bundle, because I'm mounting a source volume with on the host, and what's inside of this directory? Yeah, it's the unpacked zip file, which in this case also contains Nginx proxy definition. So you bring in the proxy definition from this application bundle, and then the container picks this up by this mount statement. And what do you else have in this directory? You have the actual configuration. This is how you init this, the default environment, and this is running a multi-container Docker. I've explained before, this could be also Java, etc. But you have the most flexible solution is to use Docker. And the region, so all kind of AWS specific stuff about the environment, which reason to use, and so on. More interesting, this is mostly a configuration for the EB command line tool. But for the deployment, there's another directory where this is called EB extensions. Like I've explained before, this is customizable. So you can put little piece of snippets, of configuration snippets into this directory and modify the system. For example, I've also changed from development to production this that I have a proxy in front of this, but I have also removed the MySQL database. And this is because I have set up an RDS database, which is running outside of the Elastic Beanstalk environment to reuse it. Typically in production, you want to assure that your database is not lost and has a separate life cycle of your application. So for this, I need to configure the environment, how to connect this, and I also need to configure that the security groups, the firewall rules, are allowing me to connect to this RDS instances. And this is some example of extending the CloudFormation specification to say, okay, also put this auto-scaling group, all the instances from this auto-scaling group into a security group called database, and this is configured to be allowed to connect to RDS. And the other thing is the data source URL. Of course, you can use other kinds of circuits configuration, but this is the easiest one. So let's see if it's working. Okay, just in time. Now here we go. Pooh, it's working. We have the same application like in development, but now with port 80 because of the proxy, and connecting to the database in RDS, not on the local machine. So this is the end of the actual live demo. Let's go back to my slides. And let's see. Good. Okay. Elastic Beanstalk, Docker. And like I've explained before, the whole ecosystem is really evolving very fast, and there are a lot of other options on the market. So if you need to check one of these solutions, I present you a little checklist what you should test or check or have an eye on if you compare the different solutions. Of course, you need to check cluster management. How do you manage the infrastructure below? You need to check how container scheduling is working. Configuration management, like we have seen before. A special case of configuration management is secrets management. Service discovery, how do you find your entities, your services? Network management, how is this configured? Load balancing, is it set up? Is it internal? Is it external? Can you combine this? Storage management, how are volumes handled? Service integration. Elastic Beanstalk is very good at integrating with AWS services, of course. There's another philosophy in other solutions, more to be a complete abstraction layer. This Elastic Beanstalk is more open and shows what is behind of it. And monitoring and logging, I've not demonstrated this, but there are also solutions like, for example, CloudWatch also supports logging and central log management and monitoring. And if you then look at the landscapes, then there are two choices. On one hand, you have the AWS built-in services. Like I've explained before, there's Beanstalk. Beanstalk in itself is based on ECS if you use it with Docker. And ECS is a more low-level container management, but it's missing a lot of features because you find these features inside of Elastic Beanstalk. Then there's also a solution called OpsWorks, and OpsWorks is also integrated with ECS or with Chef. But the integration is not as good or as deep as the Beanstalk integration. And then, of course, you have the possibility to use third-party software, not built in. And then there's a lot of this different solutions on the market. You have Kubernetes. This is from the Google guys. You can find one of the advocates in the floor below. You have Docker as a company itself with Swarm or Docker Cloud or Docker Data Center. You have the Apache project, Mesos Marathon, you have of course Fleet, you have HashiCorp Nomad, you have Zalando Stups, not so much known, but also interesting, coming from an operational perspective. And my personal recommendation would be if you are invested in AWS, currently you have some service already running, and want a managed service, so you don't want the hassle of managing the control plane by yourself, then go with Elastic Beanstalk. If you have some manpower and skill and are adventurous and want to operate the platform on your own, and then you should check out Kubernetes. Kubernetes, compared, for example, to Elastic Beanstalk and ECS, is more advanced. But a production-grade setup and running this in production, not the application, but the Kubernetes in itself, is not an easy task. You need a specialized and evolved operation team for this. And I think Kubernetes has a bright future, but currently it's in infancy. especially if you are thinking about things like long-term stability. It's like I've explained in the beginning, it's just the beginning of the whole ecosystem. And this is the end of my talk. Thank you. And if you have any questions, I will be available for questions because we are at the end of the talk. And its time is up, like explained there. Thank you.